All right, hello everybody. I'm Chris Lancet. I work at Open Robotics. I'm going to talk to you today about a slightly larger application we worked on for ROS2 Beta 2. This is running Cartographer on a Turtlebot2. So I'll go right into it. This is the hardware we're using. Nothing too surprising. That's the basic Turtlebot2 platform. You know, we got the mobility base, gets us IMU, odometry, and has all those nice platforms for mounting sensors. For compute, we're using a Pine 64 board. It's an ARM 64 board with 2 gigs of RAM and some USB connections, which we use to hook up all the rest of the peripherals. And then we have an Orbic Astra RGB-D camera to get our, it does both RGB and D, of course, depth at 640 by 480, so we use that to get our depth imagery. And then we have a joystick to drive the thing around. So this is sort of the architecture of the whole thing. All the nodes here are running ROS2, so you know everything on robot is ROS2 in this application. Those blue nodes are the sort of joystick subsystem. That'll talk to the raw joystick, get the data and publish that out as a joystick node, and then that teleop twist joy node takes the joystick data and then turns it into a command vel, which it sends down into that Kabuki node. The purple nodes are the subsystem dealing with the depth camera. The Astra node talks to the camera directly, gets the depth data, and then publishes it out to a depth image and a depth camera info that it needs. That depth image to laser scan takes that depth image and just pulls out a single laser scan line. That's done here mostly because the Pine 64 is a little bit underpowered. It doesn't really have enough processing power to do something more complete like a point cloud or something. So in this case, we're just using the depth camera as a laser scanner. And then the green nodes are some static transforms between the base Kabuki node and the cameras. And then the Kabuki node takes as input the command velocities from that joystick subsystem, and then an output it gets from the Kabuki node is odometry and IMU, and it publishes that along with a couple of TF transforms into the cartographer node. And that central cartographer node you see in the middle there takes all that data in, and that's a port of the ROS1 cartographer node, and takes all the data in, calls out to cartographer on the back end, and generates and does the slam. The output of that is there's a couple things it outputs. One is the occupancy grid that's on the map topic, and then it has a list of submaps that it's tracking. There's a few other services it outputs as well. So off robot, we might want to do something like visualize that data that we're getting off of the robot. Right now, we don't have RViz running natively on ROS2, but as you've heard several times before, we do have the ROS1 dynamic bridge. So in this case, we use the bridge to map between the ROS2 nodes, which are coming in on the far right there over the network from the robot. Sorry, the ROS2, not nodes, the ROS2 topics coming in over the network, and it will map them down onto ROS1 nodes so that we can view them in RViz. And so I have a video that this is the system running. That's running around my office at home, and then that's the ROS1 RViz doing the visualization. So while that video is running, since my time is short, I will continue talking. I just want to talk a little bit about like what it means to port a node from ROS1 to ROS2, because almost all of these nodes were ports. None of them were really written from scratch. Some of the challenges, doing the port is usually pretty straightforward. There's some changes in APIs, there's some changes to package XML and things like that, namespaces. All of that's pretty straightforward though. Where you run into some issues, excuse me, is that not all parts of ROS1 are ported to ROS2 yet. So if you need to do things like actions, if you need message filters, these are parts that we just haven't gotten to yet. Other problems is that while it's simple to do a simple port, it's mostly a search and replace. There are more complicated. We have changed some of our best practices between ROS1 and ROS2, and so while a simple port can get you up and running, it's not necessarily the best way to do things in a ROS2 world. There's that, and then cross-platform support. A lot of ROS1 code is written maybe with only Linux in mind, whereas in ROS2 we're aiming to be Windows, Linux, and Mac OS X. So there's some cross-compatibility concerns. So I think my time is up. If you have this is where you can get the code, and if you have questions, please come talk to me or email me, and that's it. Thank you.
Great, thank you. So we'll have time for one question, but in the meantime, would Ruffin, you come on up and set up so that we can go ahead. So is there a question? Great, thank you.
I saw that you had ROS core 1 on the other side of the bridge. Is that necessary to have 2 cores, or does that happen by itself?
No, so because ROS2 doesn't have a central core, so that ROS1 core is just the one you need to run.
So we have to run the ROS1 core manually on the other side?
On the other side of the bridge, yeah, that's right, exactly. Yep.